Good afternoon and welcome to our webinar on enabling speed, quality and predictability with DevOps. My name is Ross Beard. I run marketing here at Shadowsoft. Shadowsoft is an IT consulting firm headquartered out of Atlanta, and we specifically focus on enabling companies around DevOps. Doing a lot of work around infrastructure automation, infrastructure as code, and also container management. Excited to share this webinar and this topic with you today because our VP of Technology, David Rodriguez, has an interesting use case, a customer story, where he implemented some toolings and processes to really help enable this particular company around their speed, quality, and predictability. I do want to say a special thank you to our partners, Red Hat, for supporting us on this webinar. We have been a Red Hat partner for going on 10 years, and we work quite closely with them around their Ansible product and their OpenShift container platform product. So I wanted to talk a little bit about our speaker today before I pass the reins over to David. Prior to Shadowsoft, David successfully led organizations such as Intercontinental Hotels Group and Fiserv through their technology transformation journey. Now, David leads Shadowsoft's engineering team and is focused on helping clients prepare for the challenges of tomorrow and expanding Shadowsoft's capabilities around DevOps and organizational transformation. So, welcome, David.
Hello, everybody. Thanks, Ross. Appreciate it. So, if you've been following our journey here, you've been to the first two of our DevOps sessions, and today we want to talk about some of the examples, one example specifically about DevOps and why DevOps matters, and what it can do for a company that's going through this journey. So we have a case study. We'll talk about some of the business drivers, the problems. We'll talk about the solutions that we put in place, and then we can talk about some of the tools for success that you can use at your own company or that we can help you use. There we go. All right, so when I work with teams, I try to equip them on asking these kind of questions on when you should consider DevOps. And this is the why DevOps. So there's lots of reasons to think about putting DevOps in place or, more automated DevOps type tooling in place. Some of the ones that we had for my particular case study, they had some speed challenges, they had lots of quality challenges, and they had a huge predictability challenge. So as, we discussed the speed challenges. For example, when I talked to the CIO of this company, he said, it takes me far too long to get a new product from concept to production. And part of the reason for that was, it took too long for development, it took too long for testing, it took too long for the marketing group and the product team to define requirements. And, that all added to this, extensive amount of time that it took to get that product out the door. And, what that led to for that customer was, they couldn't be relevant. If I can't be relevant, I can't be competitive. And if I can't be competitive, I can't keep up with my, my customers' demands. I can't keep up with the competition. In some cases, regulations are required, and I can't keep up with regulatory compliance. So, having things that take far too long to get a product from idea to production, or even enhancements required for regulatory reasons, that's not accessible in today's technical economy. So that's one of the speed challenges. Another one of the speed challenges this CIO told me is, I can't even get a new environment stood up. Part of the problem they had was everything was being done manually. There was not an automated manner in which they could bring up a new environment. So they might put a request in for a new VM, for example, and that request would go to a group that had a ticketing queue that, might have requests from 100 other people or, 15 other teams. And, so the request just got kind of lost. And, once it was up for consideration, there might be some back and forth with the customer, with the requester. And so, maybe a week after it gets entered into the system, it might be up for consideration, and it might take 1 to 2 weeks longer to get the environment stood up. And many times, because it was being done manually, it was not repeatable. So, having a mechanism that takes 3 weeks in some cases to stand up a new environment, it just was not conducive to a good development productivity. So automation was not in place. So having these things that were all manual just, created part of the problem. Another one of the speed challenges, for this customer, this company, they had a set development life cycle. And, they had it targeted for 3-month intervals. So, every 3 months they want to get a new release out. In most cases, development could get done on time. But when they got to the end of that 3-month period, the testing requirements from other groups outside of the development group added another 10 to 14 weeks in some cases. So I could be done with my product on time, but it might take 2 to 3 months more for me to get it out to my customer's hands. So, by not having some of the things that we put in place when we do DevOps in place for this customer, it really extended the amount of time that it took to get anything from idea through development, through testing to the customer because of all of the non-development group centric stuff that had to happen. So those were some of the speed challenges this customer had. Other things that they had, quality challenges. When I talked to the CIO, he said, look, my customers, they don't trust me. And, I can't move my code into production, and I'm going out of order, but I can't move my code into production without a lot of issues. So, when I put things out there, I might test fine in my development and test environments, but when I get it into production, it doesn't work the same way that it did in my internal environment. So, that results in my customers finding defects and being very unhappy with us. Back into the development process, a lot of times the CIO says, look, I can get things developed, I can get them tested, but then as I'm getting ready to release, I find so many defects way late in the process that it just delays my release by, weeks to months in many cases. So, having those quality challenges there, create a lot of issues in making the code or making the development process more efficient. And then, one of the third things is, the code is unmaintainable. This customer had a lot of legacy code, and they were trying to intermingle that with new code. And, trying to do that and trying to maintain code that the developers who were on the project didn't create, and, trying to unravel years of development that had been undocumented and been put on top of things, that just made the code very unmaintainable. So there were multiple instances of a piece of code being changed, and that immediate change worked just fine. But the impact of things that weren't necessarily documented, in many cases, caused errors in about 10 or 15 other areas. So the tooling that was required to be able to determine impact far beyond the code that I was changing, they just weren't in place. So that created huge quality challenges. And then a final consideration or a final problem that this customer had, he said, I can't even tell my customers when my software will be deliverable. My software delivery process is so unpredictable because we always run into problems like the ones mentioned above. I just can't say, hey, look, in 3 months you're going to get this next release with these features because, I just don't know. I can't reliably make my customers trust in me because I've let them down so many times. So the unpredictability was a huge issue for this customer. So here's our case study. Some of the things that we wanted to accomplish with moving this customer into more of a DevOps model were things like this. We wanted to provide faster time to delivery for new software. We wanted to improve the quality of the software overall and reduce defects, both internal during the development process and external when the customers get the software in their hands. And we really wanted to increase the predictability of delivering the software and lower the risk. So there's lots of things that we had to consider in order to meet these objectives. So here's some of the problems. Like for this customer, speed was one of their big problems, right? It took too long to get code out to the marketplace. This customer was dealing with legacy code, intermingled with new code, and in some cases, the delivery process from concept to getting into the hands of the customer took 18 to 24 months in some cases. And even if we could get a change done quickly, a lot of times the customers weren't ready because they were on their own cycle, so that even extended it longer. So speed was a huge issue. Quality, another huge issue. A lot of times the customers would not adopt the software because they've been burned too many times in the past. I can count when I was there at least 4 or 5 times until we got this model going that we would release something and the customers just sit on it for 6 to 9 months because they weren't ready for us to, because we had burned them so many times in the past. They didn't trust us anymore. So in one case, we created a security vulnerability so the customer had to stop their production for 6 months while we fixed the problem. Another case, similar, the customers talked. So other customers did not implement the software until they heard that we had delivered solutions to this one customer's issue. So, it just created a slowness of adoption and implementation. Another one was, the quality. And we talked about, putting code in production and it causing so many defects that, customers were really wary of our quality. And we would have something that would fix a problem that would then break through the problems that had been fixed in the past because of the quality of the testing and the quality of the delivery process. So, many, many times we had a lot of customer reported defects that were found in the first, 30 to 90 days. And, we would go and try and figure out what the heck happened, and it was just, we missed the testing. So we didn't have a good process to do adequate regression testing and adequate impact analysis, so that resulted in the customers getting software that was not good. So a lot of defects. And then, like I mentioned above, unstable software. We would fix a defect as we're doing development, and that one fix created issues in so many other seemingly unrelated areas that it took us a long time to unwind all those and get them all fixed. So the software was structured in such a way that it just was not maintainable really well, and it was risky for us to do things like make a fix in one area because we didn't know what else it impacted. So quality problems were huge. And then predictability. I mentioned it a minute ago, the CIO couldn't put out a published date for when software would be out the door because, every time he did that, he had to go back and retract it and say, okay, well, I know I said it was going to be ready March 1st, but now it's not going to be ready until June. And then when June rolled around, it's not going to really be ready until July because of the inability of the software development process to be able to get software out the door. So it just took that long. And all those things lead to very unhappy customers. And I know we lost revenue and lost customers because of the unpredictability and the quality and speed issues with our software development. So here are some things that we did specifically to address some of the issues at this customer. First thing we did was we looked at the software development process and we implemented a fully automated CI/CD or DevOps solution from code check-in to software delivery. And in our previous 2 sessions, we talked a lot about the CI/CD model. In this case, this one implemented automation where code would be checked in, code would be pulled out of the repository and built. And during the build process, we would do a lot of software quality checking. And we would not let that code go forward until it passed all the requirements. So there were security requirements, there were quality of the code structure health requirements, and there were things like test coverage requirements that were all built into the build process. Unless all those things were passed, this code couldn't go forward. So that was one of the big, actually that was one of the hugest improvements right there, because we didn't let poor quality code go forward. So it wouldn't even get in the hands of the testers, for example, until it met the quality requirements that we set up for them. Another thing we did was, we automated all the builds. Before we put this in place, the build time could take, 2 to 3 days, because it was all manual intensive. And anytime we got a build request, somebody would have to go in, one of the configuration management team members had to go in, figure all the pieces that were required to build the software, and, they would build it by hand. A lot of times they didn't get all the pieces that they needed, and because they're doing it manually, they would have an error, so they had to go back to the developers over and over again, and that just created a huge delay in getting things built. And again, our average build time before we started this was 2 to 3 days. With automation, we got builds to under 4 hours, and that 4 hours included the build process itself, from check-in until the build was complete, but it also included all the analysis pieces mentioned above, which was, static code analysis to do security checking, coverage analysis for unit test coverage, and code quality analysis for adherence to the new coding standards. So all of those things were done during the build, and the longest builds took about 4 hours, and I allowed the teams up to 6 hours to get this done, because that was the amount of time from when my folks on the West Coast would go home until my folks offshore in India came in to do their work. So that 6 hours was my max window. A lot of times the builds were done in an hour or less, so the automation really helped out a lot. And because we automated the builds and we used scripting, they were repeatable and predictable. So that repeatability and predictability, that requirement was met, and the efficiency, was improved because we did it automated. So no longer do we have to do it manually. We didn't have to wait for a human resource to be available. The system did it automatically when checking was detected. So that helped quite a bit. Another thing we did, I talked about the testing time, and the specific test here that was taking 14 weeks, this was from code freeze to delivery to production. That included a lot of performance testing, it included security testing, it included final regression testing, and things that had to be done before we could get our software to production. So the movement here was to work with the performance team to understand what the requirements were, and we implemented all of the performance testing during the build process and during the delivery process. So after we had a good build, the software went to a performance scaled environment, and we did performance testing there. And this was done repeatedly throughout the development process, so that when the software development was completed, we already knew that we had performance measures met. The other thing was the security testing. We put security testing into the build process, and we put security testing as part of the pipeline, so that rather than having to have our security team do testing once we were done, we had already validated that all the things that they needed to do were tested, and there were no vulnerabilities. Now, so the 2 to 3 days that were left were, some exploratory ad hoc testing that just couldn't be automated, and some final ad hoc, pen test type stuff that, couldn't be automated from the security team. But, because we worked with them and met their requirements, we were able to get that test time reduced down to that 2 to 3 days, and that was reliable. So it was a great improvement, and that thing right there reduced the amount of time for us to get from code freeze to delivery. But the same type of automation was used during the delivery process itself, so that while we were developing the code, we were testing and checking for impact to make sure that we weren't introducing any regression issues, so that, the amount of time from defect injection to detection was, hours in many cases, or even less. So that was a huge speed improvement. And then finally, the faster time to market, because we could reduce the amount of time it took for us to do our final regression, reduce the amount of time it took for our builds, the delivery time went from months down to, in some cases, 2 weeks. We had a 3-month delivery process in place, or a delivery schedule in place, and we were meeting that on a consistent basis once we put all these changes in place. And in many cases, we could deliver several times during that 3-month window. The only problem with that was a lot of our customers weren't able to receive change that much, so we would just kind of queue them up until our quarter release, and then they would get released to the customer. So that faster time to market and being able to be relevant and being able to keep up with regulations and such, that was one of the great results of our efficiency improvements. So those 4 things are all speed related. Getting things done quicker, getting things done in an automated manner, that all helped us a ton to increase the speed of delivery. The second area that we focused on was quality. And so a lot of the time, we had to do things to improve quality. So we did things with automation. So we started out with automating the unit tests, and just having good unit testing in place helped us prevent a lot of issues that got propagated down the line, because we were finding them early on with the unit tests. In our agile development process, we also had our testers on those teams writing automation, so that as code was delivered to us for builds, we also got automated tests that are functional tests in nature. And we could do, we reuse those tests for our regression tests, so that we didn't have to write new tests, first of all, because they're already there, but we also had a great test bed that grew with every check in the code, so that as we got through the release and to the end of the release, my test foundation grew by the number of tests in each of those sprints, so in each of the stories that were delivered. So as we went through the release, we used test automation immediately during the build to prove that the build didn't break something that had to have that had worked before, and then we used regression once the build was completed to make sure that we didn't introduce any new defects. So those things there helped us ensure quality was there. And before, we had a huge amount of risk because we could not predict if a code change broke something. With automation, the risk was diminished and reduced quite a bit, because we now know that we had passing tests, and with those passing tests, we knew that the software worked. The critical functionality that had to be in there was working just as it needed to be, so that we could safely and knowingly put that software out the door. So, and then that improvement in quality and improvement in the quality of the software, that reduced the number of customer reported defects, because the things that they were finding before, which were, hey, we fixed an error here but broke 15 other things, we were testing those before it got out the door now. And using that automation and using a continuous regression model, we were always testing the changes, and we would find, during the sprint right after a defect was introduced, we find that defect, we can get it fixed, retest it, and put it back into the system. So that quality improvement was huge. And we saw the number of defects go from, well, I'd say we reduced the amount of critical and high defects by over 80% in the first, few months after the defect. So that was a big improvement there. And then predictability was increased because we knew how long it took to run our tests. Once we got our full suite together, again, we could do a full suite of testing in 2 to 3 days max. So we knew that if we had a deliverable that was set to go out on March 31st, we knew the things that we needed to do, and we knew if we started our testing a few days before, we should have everything ready to go. So the predictability improved immensely, because we knew that it takes this long to get the job done. We scheduled that amount of time if we can get it done fine. And again, we reduced the risk because we automated everything. We knew that these tests must pass in order for the software to be ready to go. So we made sure that they all passed, and that reduced the risk of releasing something that would break in production. So there you go. For this particular customer, we used a subset of tools that are part of the DevOps suite. And, we talked before in the previous two sessions, there's lots of tools that can be used for your CI/CD models or your DevOps models. The ones we haven't used here are shown on the screen. We needed to do something to manage our code, so we were using Subversion, and we had Jenkins in place. And, as we went through the pipeline, we used a tool like SonarQube, and, we had Ansible and other things like that. But these were all part of the mix that worked for this implementation. And, so there's tools that you can pop in and out, but this was the one that made sense for this customer. And, by putting this combination of tools in place, we were able to get that system that was fully automated, fully able to take code from check-in to delivery, and, be able to provide our reduced risk and greater predictability. That's kind of what we did there. And so, having folks that understand how to put these tools together and having folks that can make them talk to each other, that was a big part of the challenge that we had to do, because when I took on the task and took on the team was really focused on just getting an automated build in place. And that was their task for the year prior to when I adopted the team. And, I told them, look, this isn't big enough. We need to think bigger. So we built our DevOps model, built our CI/CD pipeline, and built a tooling in place that would work for that particular implementation. And, if you go and look at all available tools for every piece of a good DevOps pipeline, you'll find your own set. But, I took some of the things that I had in place at the company already and integrated them with pieces that I use all the time, and that created a successful model for us. So, this is just one set of tools. Your company might have a different set of tools. So, this is kind of the end of this presentation. In summary, we had some challenges with speed, quality, and predictability, and a lot of them were met through using good tooling and good automation and just good development practice to improve those things. The speed was improved because we used a lot of automation. Quality was improved because we used a lot of automation. Predictability was improved because we used automation. And those were all part of the DevOps tool sets that we put in place. And really the end result for us, which made the biggest difference, was our customer satisfaction went through the roof. They were no longer calling, hours after we deployed a new piece of software saying, hey, you broke something. They were calling for different things that we'd never come across now. And the amount of critical and high incidents that we got in production in the first 3 to 6 months after release dropped tremendously. And like I said, in the case of this customer, I think it was an 80% plus drop in customer reported defects in the first 90 days. So that was a huge improvement. And, so this company leveraged the tool set that we put in place in the first group, and we put it in place in another group as well while I was there. So it made it a good model, and that's usually, or that is now the foundation for a lot of the DevOps stuff that we do here at Shadowsoft. So.
Okay, thank you, David.
Thank you.
Appreciate you sharing some of those ideas and then talk through how you approached tackling some of those challenges around speed, quality, and predictability with that particular customer. I wanted to wrap things up today with a small offer. David talked particularly at the end there about understanding the tools and how to get the tools to talk to each other as being a key component to achieving or solving some of those problems around speed, quality, and predictability. At Shadowsoft, DevOps is a strong capability. Specifically, the tooling around the DevOps chain is where we've had a lot of experience and we've helped a lot of customers. So if you're looking for help with maybe infrastructure as code, infrastructure automation, container management, and you have a vision for it, but you're not too sure how your team is going to get enabled on these toolings or how you're going to integrate these toolings, an assessment is a great place to start. We can come in, David and his team can come in, look at your pre-existing tools, we can assess integration with your tool chain, and then you'll walk away with a report that can help you understand where the gaps are and give you some recommendations on how you should move forward. So there's a little pop-up that will come up on your screen here now. Follow that to the link, and you can learn more about this assessment. If you're watching the recording, it will be below in the description. Okay, that's all we've got here today. The final component of the webinar is Q&A. I'm going to welcome David back into screen here, so we both can sneak on here.
There we go.
Does anyone have any questions that you'd like to ask David over the next couple of minutes, just to wrap up? Doesn't look like we've got any. David,
That means we did a great job.
we did a great job. Are there any final thoughts, David, that you want to leave the audience with?
Yeah, I mean, just, every DevOps journey is, it's different, right? So, there's just not one, it's not a cookie cutter solution. And, every customer I've worked with, it's different challenges, it's different things that, we need to address for that customer. So, part of the beauty of these assessments that we're talking about, it allows us to come in here and learn your environment and learn your specific challenges so that we can go and come up with a solution that works for you. And many times the solution is a combination of what you already have and a combination of what we think we can, put in there to fill in the gaps. And, that's part of what we do for our assessments. And we've been highly successful helping our customers get there. So yeah, if you have interest, just let us know. We'd love to come and talk with you and, be able to help you on your journey.
Thanks, David. So thank you all again for watching this webinar. Follow us on YouTube to see more webinars and recordings, and be sure to keep an eye out on your email for future webinars that we plan in the not too distant future.